All right, so basic example. So this is my balanced chemical, well, not balanced, my unbalanced chemical equation. This is my redox equation. It's in basic conditions. Okay, so to think about what that means. And the question that I'm asked is, what is the coefficient in front of Ag2O, silver oxide? Okay, so I'm looking for what's the coefficient when this is all balanced. So pause here and go ahead and separate your equation into two halves, and then come back. Okay, so hopefully you got this equation right here. Now we are going to balance all elements other than oxygen and hydrogen. So pause here and balance everything except for oxygen and hydrogen. Okay, this looks like ZUs. Z ends. Okay, so hopefully this is what you got. Okay, so this is just like the last one. Now we're going to add waters to balance up the oxygen. So pause here and do that. Okay, so it's getting a little redundant to write ZN2 plus with Z over and over again, but we're going to do it just to make sure we're following all the rules. Now we're going to add protons to balance out the hydrogens in the water we just added. So pause here and do that. Mm-hmm. Mm-hmm. So hopefully you added 2 protons to the right hand side to balance out the 2 hydrogens in the water on the left. Now we're going to balance the charges, so go ahead and pause here. Make sure you calculate your charges and determine where to add the electrons. Alright, so coming back, I see I need to add 2 electrons on the right hand side of my equation on the left, and then I'm going to add 2 electrons to the left hand side of the equation on the right. So you may remember we said we're never going to add the electrons on the same side. So because I knew I needed to add them on the right up here, I know they must be on the left in my other equation. So the nice thing is there's no change to my equation because I have 2 electrons and 2 electrons. So that's great. I don't have to, well, let's not be lazy. Let's rewrite. Okay, so there's no change to the any of the coefficients because I have 2 electrons in both of my half reactions. So they're going to cancel out without any problem. And now I'm going to add them together. Oh no, my whole line went away. So now I'm going to add. First thing I'm going to do is cancel out the electrons. I feel like I'm going to get into trouble forgetting something, so I try to check everything off, even the arrow, because the arrow is important. All right, so if this was acidic, this would be done. The answer would be 1, but it's not acidic, it's basic. So what we're going to do here is I'm going to add however many protons I have. So in this case, I have 2 protons on the right, and I'm going to add 2 hydroxides to form water. Okay, and nothing else is going to change. Oh, writing these backwards is hard. Okay, Now I have to look at my waters because I can't have waters on the left and the right, so I need to simplify my equation. And when I simplify, so I'm going to simplify. When I simplify, I'm going to reduce that. I'm going to get rid of the one on the left, and the one on the right is going to go to 1. So my final answer is this equation right here. And this is balanced in a basic medium. I know it's basic because it ends with hydroxides, or has hydroxides. This one's acidic because it has protons. So the question asked, what is the coefficient in front of the silver oxide? Well, it's 1. So that would have been your answer. You would type in. Yes, you could always guess 1. I would not recommend it, but you could. All right, so hopefully that helps give you another example of balancing a reaction in a basic equation so that you can prepare for your quiz and your tests coming up.